one came out in 2002 by Robin Hanson, an economist at George Mason University. And it's called logarithmic market scoring rule. The problem with it is if you and I each have 10 shares of an outcome, and I buy one more share on one of the sides. So in a traditional like parimutuel wager, the odds should be around 50-50 because we each own 10 shares. With LMSR, instead the price will jump a lot. It'll jump to like 70-50. And that's because it doesn't really have any sense of liquidity. So instead what we use is something called liquidity sensitive LMSR. So as the market volume increases, so let's say we now have 100 shares on each side, and I buy 5 shares on one of the outcomes, so now it's 105 and 100. The share price will only increase to something like 53 cents. There's a few other fancy types that don't really work as well. One's made by Microsoft. It's called the volume parameterized market scoring rule. And the last one is basically one that allows you to make more profit. But the problem with that is people can set the odds. And so that works well for things like if you're wagering on sports, but it's not really good for information. So the main aspect of our system is determining outcomes of events. So with InTrade, the fees go to InTrade, and there's no punishment if InTrade manipulates the results. With our system, instead, we have people report on outcomes. So you have this score called reputation, and the more reputation you have, the more your report is weighted. You also get part of the trading fees from markets. So half the trading fees go to people who make the markets, so anybody can make a market. Then another half go to reputation holders. So there's basically categories of reputation. Initially, everything will just start off in one main category. It's kind of like a tree. And so the main category, basically every 2 months, you'll get a list of events in our system. And you'll have to report on them. Did this happen? Did it not happen? Was it rainy? Was it cloudy? Was it sunny? Et cetera. And so all this stuff is compiled into a matrix. So on the columns, you have events. And on the rows, you have users. So one easy thing to do is say, well, let's just have people vote one at a time on each event. The problem with that is you can collude really easily. So instead, we say, let's have people vote on a ton of things at once. So if you want to collude in our system, you not only have to collude on the one event you want to collude on, you have to collude on everything else. So let's say it's a reporting cycle. It's been 2 months. It's time to report. And you want to collude on an election. The way we do it with this is you would have to collude on every single other event in the market, which is pretty hard because, one, your things are hashed. So if you leak the information, how you're voting, people can steal your reputation. And so the only way you'd be able to collude is hopefully you'll trust what I'm saying, and you just have to believe me. So if I say, let's collude and let's say that Hillary Clinton didn't win even if she did, well, in that scenario, you're just going to have to trust me. And the problem with people who are colluding and lying anyways is it's not easy to trust them. And the mechanism we do this with is something called principal component analysis. And basically, the way it works is the more different you are than the consensus, the more you affect this thing called the principal component. So as you can see in the bottom right, people who affect the principal component more lose more reputation. And it's just basically a relative scoring. So you can lose up to 20% of your reputation in a voting cycle. When we decided to do this, there were a few decisions we made. One is, you can build it off of Bitcoin. The problem with Bitcoin is it's really hard to extend. It behaves really well as Bitcoin, but when you try to add things on top of it, it tends to, you add one thing and 4 other things break. So instead, we decided to use Ethereum. It's much more scalable for what we're using it for. We also don't have to deal with the low-level security. And it's much faster as well for us to build with. So Bitcoin, we started off building on Bitcoin, and it took us about 6 weeks to implement a basic feature of creating events in our system. When we did it with Ethereum, it took us 5 days. The other question we get a lot is why not just use Counterparty? Answers differ on this. Some of the developers say they want to support sidechains. Some of them say they don't. With Ethereum, we have Vitalik saying that they will support sidechains, which is much more secure for us. And there would be a few other ways to do it with Counterparty. You could issue a Counterparty asset from a contract, except you can't do that. Or you could use their sort of pseudo Bitcoin they used to have, but that got removed because the people who made it were worried about regulatory risk. It's also much harder to store data on Counterparty, because with Ethereum, data is stored in these things called Patricia trees. And so with Ethereum, you have all the data, and then you have blocks, and the blocks basically modify the data. Whereas with Bitcoin and Counterparty, you just store all the data in the blocks. So it's much more data intensive. And so our contract has a few functions. You can send money around. You can send reputation around as well. You can make a branch or a separate subject. You can make events. You can add those events to markets. You can buy and sell shares in the events. And finally, you can report on the events. Another thing we were thinking about is using a stablecoin. So if you're wagering on something and it takes place in 2 days, it's fine to use Bitcoin because the volatility risk in 2 days of Bitcoin, well, sometimes it is, but it's usually not that bad. If you're betting on something 5 years from now, you're pretty much betting on the price of Bitcoin as well, which you don't want to do. So instead, you could use something like a stable cryptocurrency. There's a few routes for this. One is the idea of like Hayek money, which was presented here a couple of days ago, or yesterday, I think. And the other one is contracts for difference. So contracts for difference basically allow you to have a prediction market. Let's say it's the standard Hillary Clinton example. And instead of just 2 outcomes, yes or no, you also add 2 more outcomes. And the other 2 outcomes are, do you want to say yes, Hillary Clinton, and you want to be long Bitcoin? Or do you want to be yes, Hillary Clinton, and long US dollar? And basically it ends up working out that the people who long Bitcoin take on twice the volatility risk of Bitcoin, and the people who long USD basically just get, if you wager $10, you wager $10 and that's it. You're not dealing with volatility of Bitcoin. The good thing about Hayek money though, is you can use it in systems besides ours. Contracts for difference, it's just limited to our system. The other thing you can do is, so a lot of people say, well, why not just use reality keys instead of a decentralized reporting mechanism like we use? So the problem with using something like reality keys is basically this service, and it uses this API called Freebase. And what it allows you to do is you basically can look at any event and it'll give you the outcome of that event. So let's say it's a sports game, and you look it up on reality keys and it says the outcome of this match was Manchester United won. Well, the problem with that is reality keys is centralized, so reality keys could falsify the outcome. They could also get shut down or hacked. So instead what we say is, let's say you're reporting on sports matches. You could report on each sports match individually and do it manually, or what you could do is hook up an API and have it report for you. And the cool thing about this is it basically allows you to vary how much centralization you want. This is similar to how Bitcoin does it. It starts out decentralized, and people add layers of centralization on top, depending on how comfortable they are with that. And there are a few other applications of our software that aren't just prediction markets. One is decentralized Oracle use. So all these reporters, you can use them to be an Oracle system for anything. So with systems like Ethereum and actually any other smart contract system, one of the biggest problems is you want to get information that's outside of the blockchain. The problem with that is most of these smart contracts are executed in trusted environments that don't connect to the internet. And even if you did connect to the internet, you'd have to connect to a trusted third party. So what you can do with our system is you can propose a question to the oracles, and you can get a resolution of that question, even if you don't include it in a prediction market. So an example of this is weather. You could ask our oracles, what's the weather on some day? And they would report the weather was this many degrees, et cetera. And the final example is you can use peer-to-peer wagers. So you can use the outcomes of our oracles to basically allow you to do peer-to-peer wagers with your friends. You don't have to actually buy and sell shares in the prediction markets. And the cool thing about prediction markets are you can ask anything. So basically any financial market is almost a subset of prediction markets. whether it's stocks, derivatives, whatever. Anything is almost pretty much a subset, and that's it.
All right, time for a couple questions before we have our afternoon break. Sebastian, question? Yep.
So you mentioned APIs and so potentially using reality keys. Could you explain just how like the degree of centralization that can be removed? I didn't quite understand that. Could you elaborate on that?
So, so with our system, instead of just trusting like one centralized third party to report on the outcomes of events, we have a bunch of people do this. So we just basically ask people. It's the simplest thing to do. And the idea is that truth is basically a Schelling point. A Schelling point is basically the solution that people come to in the absence of communication. So let's say you're given the task to meet up with a certain person in New York City. All you know is their name. The Schelling point for that tends to be you meet up at the Empire State Building at noon or the Statue of Liberty at noon. And so we basically just ask these questions to people. And the idea is you have thousands of people reporting on the outcomes of events instead of just one third party. And the thing with reality keys is they just have the reality keys guy and that's it.
So maybe one brief question. So one of the things I'm a little bit concerned about here, so when you have these people reporting on the outcomes, if I understand it correctly, right, if I own reputation coin, basically some stake in the system, then I am supposed to do this, right?
That's correct.
So obviously this is a total pain and I wouldn't prefer have someone else do it for me and get the same reward. So do you expect to see some sort of voting pools, like some of the mining pools that will make those decisions? And then the problem I would see with this is because you punish outliers, I mean, the only equilibrium there is that there's one pool left and you end up with complete centralization.
So with pools, I don't see pools being a huge issue because of the fact that you basically have to trust the pool. And so the only way to prove that you're going to vote some way or report some way is to show somebody your salt in your hash in your report. And if you have those things, you can basically steal their reputation. And so there's no way of knowing whether other people are actually going to report the way they say they are. So we could make a pool and all agree to report to something, but it's actually in my incentive to ignore the pool and vote what's actually true, because then I'll get reputation from all you people who tried to do the pool. And so it basically just becomes this huge recursive prisoner's dilemma, and that's the idea.
Hi. Can you sell reputation?
Yeah.
Well, who buys it?
Whoever wants to.
So I can just buy a bunch of reputation, then I have a really big weighted Oracle score or reporting score, and then I get really rich, or what?
So you could buy a bunch of reputation. You'd probably only get really rich if one of two aspects. One is if you buy less than 65%, then you would have to report with the correct outcome, otherwise you'd lose your reputation. If you wanted to try to cheat the system, what you would do is you would buy greater than 65% of reputation, and you would basically decide the consensus. The problem with that is it's hard to buy 65% of something because the price immediately shoots up as soon as you do.
Okay. I just have one more short question. You said it's share-based for the prediction, like is Hillary Clinton going to be elected, yes or no? Mm-hmm. And it's like a share. Can I trade the shares before the event is over?
Yeah, so the cool thing about LMSR is it's not like a standard pure mutual bet where you put your money in and you can't do anything with it until after the fact. With these market scoring rules, you can sell at any time. So if you buy at 10 cents and the market shoots up to 60 cents, you could sell then immediately, which is kind of cool because it provides arbitrage opportunities. It's like, let's say you're betting on let's say if it ends up being Jeb Bush and Hillary Clinton, and the odds start off at 90-10, even if you think Jeb Bush isn't going to win, you still buy Bush shares at 10 cents because some other person's going to buy them and the odds are going to even out to probably something like 60-40. So you can still make a profit even if you know the answer is wrong.
Micah from Gem here again. This is really cool. I like it. I'm curious, in your opinion, what percentage of the users of this application do you think will be human users, and which percentage do you think will be automated AI bots trading?
I think the majority will be human. Probably maybe, a few years from now, maybe something like 90-10. I guess the thing with bots are, with prediction markets, you can actually make a good amount of money just using bots because, as I explained with the arbitrage opportunity, there are people who have made bots that nobody's actually used them because prediction markets haven't really been done in practice besides in trade. But they basically profit off the exact same mechanism of you buy shares when there's a huge spread, even if you think the outcome's not going to happen. And so there'll probably be bots for that.
I could see this as a really good training ground for machine learning to learn how to predict the future.
Yeah.
All right, great talk. It's time for our afternoon break. Let's give them a big round of applause. Nicely done.